Good morning, all of you. Welcome to say JN the Rank Zone. So today we are going to discuss 17th group. So far we have finished. Now we are going to discuss 18th group elements in this lecture, and we'll finish up this in 1 hour only because it's a very small chapter and it's most important also because you may expect a question from this chapter for the entrance examinations. So 18 group elements in this chapter we are going to discuss. So let us start now. 18 group elements. These are also called as noble gases. So what are noble gases? Right now we'll discuss. Please listen carefully. It's a very simple topic, and mostly it is theoretical questions you'll get and structure-based questions also you'll get from this chapter. So let us start. Group 18 elements include helium, neon, argon, krypton, xenon, and radon. These gases are chemically less reactive and form very few compounds. Hence, they are called as noble gases, and even they are also called as zero group elements. Zero group elements because their valence is zero, as their valence is equal to zero. So they are also called as zero group elements. So noble gases, zero group elements. Helium, it has 2 electrons except helium. Except helium. Neon, argon, krypton, xenon, and radon has octet. Octet means 8 electrons in the valence shell. That's why they are stable. As they are stable, so they do not form any compounds. Even helium is also stable. It has two-plate structure. It has two-plate. Two-plate means in the sense 2 electrons in the valence shell. 2 electrons. That's why it is two-plate. And remaining are octet. Neon, if you take, it is 8 electrons. Argon, krypton, xenon, and radon. So this is the introduction of noble gases. These are also called as zero group elements because their valence is equal to zero. And all the noble gas elements are monoatomic gases. Their molecules are consisting of only one atom. So they are called as monoatomic molecules. Monoatomic molecules. Let us see what are the things we are going to do in this chapter. Occurrence. All noble gases except radon occur in the atmosphere. Radon is radioactive. Their total percentage in dry air is about 1% by volume, of which argon is the major component. So argon is a major component. In dry air, in atmospheric air, argon is a major component. So they form 1% by volume. The atmospheric abundance in dry air is argon is greater than neon, krypton, helium, and xenon. Radon is radioactive and is obtained by a decay of product of radium. Helium is the second most abundant element in the universe because all the stars are made up of hydrogen and helium. All the stars in the universe, because universe is bigger than Earth, so all the stars are made up of hydrogen and helium. So that's why first most element is hydrogen in the universe and second most abundant element is helium in the universe, not on the Earth. On the Earth, first most element is oxygen, since already we know. So I hope it is clear. So this is the occurrence of noble gases. So noble gases occurs in atmosphere, that is dry air, about 1% by volume, except helium. So helium also, except radon. So the atmospheric abundance in dry air is the follows the order: argon greater than neon, greater than krypton, greater than helium, greater than xenon. Next, continuation. General trends in noble gas: electronic configuration, atomic radii, ionization enthalpy. So the general outermost configuration of noble gas is NS2-NP6 except helium. For helium, it is only NS2, and remaining it is NS2-NP6. 2s2-2p6, there is 1s2, 3s2-3p6, 4s2-4p6, krypton, xenon 5s2-5p6, and radon 6x2-6p6. So radon atomic number 86, xenon 54, krypton 36, argon 18, neon 10, and helium 2, the atomic numbers. So that's why for writing potassium, what you write, we'll take argon. Argon is what? So we can say 1s2, 2s2, 2p6, 3s2, 3p6. This is argon and this is 4s1. Sorry, yes, 3p6 afterwards 4s1. So this is the configuration, total configuration of potassium. So for this we can write as potassium atomic number is 19. So we can write in inert gas configuration, that is argon 4s1. Argon 4s1 represents 18 plus 1, 19. Like that, helium 2s to 2p6 means after helium we have 8 electrons in the valence in total. So for that neon we'll write helium, neon, argon, krypton, xenon. I hope it is clear. So there is a noble gases electronic configuration. All the noble gas except helium has 8 electrons in the valence shell. Next, atomic area. Atomic area increases down the group with increase in atomic number. As we already know, atomic area in any group increases down the group because with the increase in atomic number. As atomic number increases, number of shells increases, due to which what happens, the size of atom increases. As the size of atom increases, the atomic radius also increases. Ionization enthalpy. It is very, very important. Ionization enthalpy decreases down the group with increase in atomic size. But due to stable electronic configuration, these elements have very high ionization enthalpy because they have completely filled orbitals. Since they have completely filled, in case any take, if we take, since they have even helium also, since they have completely filled orbitals, it's very difficult to remove electron from them. That's why due to stable electronic configuration, these elements have very high ionization enthalpy. Whereas within down the group, the ionization enthalpy decreases down the group because with the increase in atomic size. I hope it is clear. Next, continuation. Electron gain enthalpy. Noble gases have no tendency towards electrons because they're already stable. So they have no tendency of accepting electrons as they have completely filled outermost shell. The electron affinity values are highly positive, even though they are non-metals, but they are having high electron affinity values, that is positive values, not negative values. So they do not have any tendency to accept electrons or to gain electrons. So that is called electron gain enthalpy. So they have positive values of electron gain enthalpy. Actually, electron gain enthalpy should be negative, but they have positive values because they have no tendency of accepting electrons as they have completely filled outermost shells. Next. Physical properties. All noble gases are monoatomic gases, as I already told you. All noble gases are monoatomic in nature. So they are nothing but monoatomic molecules. And they are almost, so all the noble gases, they are colorless, odorless, and tasteless. They are sparingly soluble in water. And they have very low melting points and boiling points since they are gases at room temperature. As they are gases at room temperature, so their melting points and boiling points are very, very low. And this is due to weak interatomic attractions due to London forces. They have low melting points and boiling points, and even they are gas at room temperature. Helium has the lowest boiling point of 4.2 kelvins, very, very less. So already helium is a gas. So helium is a having lowest boiling point. So the boiling point order, helium less than neon, less than argon, less than xenon, less than krypton, then xenon. And a bit, since it is not clear. So less than argon, helium, neon, argon, krypton, less than xenon. This is the order. Next, continuation. Solubility in water. These gases are slightly soluble in water. The solubility increases down the group. As we go down the group, the solubility increases. When polar water molecule comes near the noble gas, it induces dipole in the noble gases. What it induces? Dipole in the noble gas. As a result of this induced dipole interaction, the noble gas dissolved in water. As the size of the atom increases, the extent of polarization increases and the solubility increases from helium to xenon. So the solubility increases from helium to xenon. So is the solubility order, the solubility in the water is the order. I hope it's clear. It's not that much important. Whichever is important, I'll tell you, mark that. Next, coming to chemical properties, noble gases are chemically inert because they do not form any compounds due to the following reasons. They have completely filled electronic configuration in their valence shell, that is 2 and 8 electrons. They have high ionization enthalpy and more positive gain enthalpy, electron gain enthalpy. So no true compounds of helium, neon, or argon are yet known. Only we have compounds of xenon and krypton, only few, that too. Xenon and krypton only can form compounds, that is only few compounds they'll form, only few compounds. So that's why the chemical properties of inert gas is very, very easy because only xenon and krypton can form compounds in which xenon will form more number of compounds because of low ionization enthalpy. The first noble compound prepared in the lab, it is prepared from, so Neil Bartlett prepared O2PTF6, that is dioxin platinum hexafluoride. And from this, he observed that the ionization, first he prepared not the noble gas compound, he prepared O2PTF6, that is oxygen dioxin platinum hexafluoride. From this compound, he observed that the ionization potential of oxygen, that is 1175 kilojoules per mole, is comparable with that of xenon because it is 1170 kilojoules per mole. So, as the ionization potential of oxygen is matching with xenon, he prepared the same compound and he prepared the first compound of xenon as xenon platinum hexafluoride. What is this compound called? Xenon platinum hexafluoride. First noble gas compound prepared in the lab by Neil Bartlett. So Neil Bartlett is a person who prepared first noble gas compound, that is xenon platinum hexafluoride. Xenon platinum hexafluoride. And how does he got that idea? He got that idea that the ionization potential of oxygen is 1175 kilojoules per mole. So when we can give this much of energy to oxygen gas, one electron is easily removed from oxygen gas. And the ionization energy of xenon is also 1170 kilojoules per mole. So why can't we remove the electron from this? So he thought that, and he removed electrons and he formed a product called xenon platinum hexafluoride. I hope it is clear. So the first noble gas compound prepared in the lab was xenon platinum hexafluoride. And next coming to xenon compounds. So after first preparation, more compounds came into existence. Xenon forms many compounds with highly electronegative elements like fluorine and oxygen only. So xenon forms compounds with highly electronegative elements like fluorine and oxygen. So xenon forms XeF2, XeF4, and XeF6 with fluorine. So it forms three compounds with fluorine. That is, excess of xenon, if we take into consideration on reaction with fluorine at 673 kelvins bar, 1 bar pressure, 673 kelvins temperature, and 1 bar pressure, it forms xenon difluoride, XeF2. Similarly, xenon and fluorine, the ratio 1:20 ratio, it forms 3 moles of fluorine at 573 kelvins, less temperature and high pressure. It forms xenon hexafluoride. Similarly, xenon, when combined with 2 moles of fluorine gas at 273 kelvins and 7 bars, little bit high pressure, it forms xenon tetrafluoride. And xenon tetrafluoride plus O2F2 forms xenon hexafluoride plus oxygen. So all these reactions are important because they'll ask in the examination, entrance exam. So please note down these reactions. All the reactions are important. So xenon forms three types of compounds with fluorine, that is xenon difluoride, xenon tetrafluoride, and xenon hexafluoride. Not only the reaction, they'll ask the hybridization of xenon, shape, and shape of xenon, number of lone pairs and bond pairs in these compounds. That type of questions also they'll ask in the examination. So we'll do all those questions anyway. Now, so xenon forms compounds with highly electropositive elements, highly electronegative elements, sorry, highly electronegative elements like fluorine and oxygen. Xenon forms xenon difluoride, xenon tetrafluoride, and xenon hexafluoride. I hope it is clear. Continuation. Properties of xenon fluorides. Xenon fluorides are colorless crystalline solids. These xenon fluorides, they are powerful fluorinating agents. They are called as powerful fluorinating agents and they are readily hydrolyzed. So xenon difluoride, on dissolving in water, it forms xenon 4HF, 4 molecules of hydrogen fluoride acid, and 1 molecule of oxygen gas. So xenon difluoride on hydrolysis forms xenon. It gives out xenon. Next, continuation. Xenon fluorides react with fluoride ion acceptors to form cationic species and fluoride ion donors to form fluoroanions. So this is very, very important concept for JEE mains, advanced and NEET, for all entrance exams. Xenon fluorides react with fluoride ion acceptors. Fluoride ion acceptors means PF5 to form cationic species and fluoride and donors to form fluoroanions. You can see here. So xenon difluoride on reaction with phosphorus pentafluoride, it forms XeF plus cation species and PF6 fluoroanions. And xenon tetrafluoride on reaction with antimony fluoride, antimony pentafluoride, it forms XeF3 plus XBF6 minus. So they'll ask these questions. And xenon hexafluoride on reaction with MF, that is metal. That metal can be sodium, potassium, rubidium, or cesium. So with metallic fluorides, it forms M plus and Xe7 F7 minus ions. I hope it's clear. So all these points are very, very important. So please note down in your classwork. From this, definitely you'll get questions in the entrance exam. How they exist in water, how they exist, like that they'll ask in the questions. Anyway, we are going to discuss that questions in the coming session. Next, shapes of xenon difluoride, very, very important as I told you. Xenon difluoride has linear shape and due to sp3 hybridization of xenon with three lone pairs of electrons, as it is undergoing sp3 dehybridization even though, but due to the presence of lone pairs of electrons, it is taking linear shape. Linear shape. So it is formed in the first excited state of xenon. Excited state of xenon is 0, 1, 0, 1, 0, 1, and 0. So no need to take all these things. Simply straight away we can say xenon difluoride. Xenon has 8 electrons in the valence shell. 1, 2, 3, 4, 5, 6. 1 electron here, 1 electron here. So it has 8 electrons in the valence shell. 8 plus 2 monovalent atoms attached. So 8 plus 2, 10. So it has how many bond pairs? 3 bond pairs, 3 lone pairs, 2 bond pairs. So that's why, since it contains 3 lone pairs and 2 bond pairs, so n factor is equal to 5. As n factor is equal to 5, it undergoes sp3 dehybridization. As it contains lone pair of electrons, it has linear shape. What shape it has? Linear shape. This is called linear shape. I hope it is clear. It is formed in the first excited state of xenon. First excited state of xenon is 0, 1, 0, 1, 0, 1, 0. And here this is the means the number of electrons in xenon. 1, 2, 3, 4. So it has 3 lone pairs, 1 bond pair. So 1 bond pair, this is first excited state, and remaining 3 lone pairs. These are all lone pairs. So this is lone pairs, 3 lone pairs, and this is 2 bond pairs. And 1 electron is coming from this to here. I hope it is clear. So this is called xenon difluoride. Next, xenon tetrafluoride structure. XCF4 has these structures they'll ask in examination. XCF4 has square planar shape due to sp3d2 hybridization of xenon with 2 lone pairs of electrons. It is formed in the second excited state of xenon. Second excited state of xenon. So let us see the structure. So this is XCF4. Xenon has 8 electrons in the valence shell, out of which 1 electron is contributed with one fluorine, second electron, third electron, fourth electron. So remaining 4 electrons will be kept as 2 lone pairs. So it has how many lone pairs? Since it has 2 lone pairs, 2 lone pairs, because 2 lone pairs and 4 bond pairs. 2 lone pairs plus 4 bond pairs implies N is equal to 6. N is equal to 6 means sp3d2 hybridization, and due to the presence of lone pairs, it has square pyramidal shape. What shape? Square planar shape. Sorry, square planar shape. Even though it is undergoing sp3d2 hybridization, but it has square planar shape. So, like these questions, they will ask in the examination. Anyway, we are going to discuss the questions after finishing the lecture. Next, structure of XCF6. It has one lone pair. So xenon hexafluoride has a distorted octahedron. What is the shape of the xenon hexafluoride? Distorted octahedron shape. And the hybridization is sp3d3 because 1, 2, 3, 4, 5, 6 bond pairs. 6 bond pairs plus 1 lone pair. So n factor is equal to 7. If n is equal to 7 means it is what type of hybridization? sp3d3, 1, 3, 4, 4 plus is 7. So sp3d3. So it has 1 lone pair and 6 bond pairs. Notice the shape of this xenon hexafluoride, distorted octahedron. It is formed in the third excited state of xenon. First excited state, xenon difluoride. Second excited state, xenon tetrafluoride. Xenon difluoride, first excited state. Xenon difluoride, second excited state. Xenon hexafluoride, third excited state. So in each and every excited state, two electrons. That's why the 6 XeF6 is formed. I hope it is clear. Next, continuation. Compounds of xenon with oxygen. Compounds of xenon with oxygen. Hydrolysis of xenon tetrafluoride and xenon hexafluoride with water gives xenon trioxide. Very, very important. How we will get oxides of xenon? As already we know, xenon can form compounds only with oxygen and fluorine, most electronegative elements. So how does it form xenon oxides? So xenon tetrafluoride and xenon hexafluoride on reaction with water forms xenon trioxide. Example, you can see xenon tetrafluoride on hydrolysis forms xenon plus xenon trioxide plus HF plus O2. Very, very important reaction. And xenon hexafluoride on hydrolysis will form xenon trioxide along with hydrofluoric acid, that is HF, hydrogen fluoride. So these two reactions are important. They'll ask in the examination. So we'll get xenon oxy compound, that is xenon trioxide. Next, continuation. Xenon trioxide. Continuation. Partial hydrolysis of xenon hexafluoride gives oxyfluorides. Partial hydrolysis of xenon hexafluoride gives xenon oxyfluorides, xenon dioxide fluoride, dioxygen difluoride. So these two reactions are also now important. Hydrolysis of xenon F6 is not a redox reaction. Very, very important. The hydrolysis of xenon hexafluoride is not a redox reaction. This point also they can ask in the competitive exams, entrance exams. So each and every point is clear. It's very, very important also. I hope it is clear. Next, continuation. Structure of xenon trioxide. Xenon trioxide has pyramidal shape due to sp3 hybridization. Xenon trioxide. Trioxide means it contains how many bond pairs? Each xenon has 6 electrons, 8 electrons, 1, 2, 3, 4, 5, 6. So one bond pair, two bond pairs, three bond pairs. So three bond pairs, and here one lone pair is there. So these three oxygens will form. So three bond pairs, one lone pair. So that's why it is equal to 4. If n is equal to 4 means it is going sp3 hybridization. So as is undergoing sp3 hybridization, but shape is not tetrahedral because of one lone pair of electrons. As one lone pair of electron is there, it is pyramidal shape. What shape? Pyramidal shape with one lone pair of electrons. It is a colorless explosive solid. It is formed in the third excited state of xenon, because from xenon hexafluoride only we got this. So it is formed in the third excited state of xenon, because 1, 2, 3, third excited state of xenon. I hope it is clear. Continuation. So xenon, three triple bonds, p pi bonds, and p pi d pi bonds. So it has three p pi bonds, three pi bonds. So three sigma bonds and three pi bonds, because three double bonds are there. So number of pi bonds and sigma bonds in xenon trioxide is three sigma bonds and three pi bonds. And the p electron of oxygen combines d electron of xenon, and that's why it is called p pi bonds, p pi d pi bonds. So p pi d pi bonds, and it has one lone pair. So it is formed in third excited state of xenon. So shape is pyramidal shape, and sp3 hybridization. I hope it is clear. This is very, very important. Structure of xenon trioxide is most important. From this structure-based question, they will ask. Next, structure of xenon tetroxide. Xenon tetroxide has a tetrahedral shape because all the four valence of oxygen have been, so xenon, 8 electrons of xenon, so 4 bond pairs. So due to sp3 hybridization of xenon, it is a colorless explosive solid. Since there is no lone pair, so it will take the shape of tetrahedral shape. It is formed in the fourth excited state of xenon. Which excited state? Fourth excited state of xenon. So this is called xenon tetroxide. Xenon tetroxide. Next, xenon oxygen tetrafluoride. Xenon oxygen tetrafluoride has a square pyramidal shape. Square pyramidal shape due to sp3d2 hybridization of xenon with one lone pair of electrons. Actually, xenon has 8 electrons. So 2 electrons here, 1, 3, 4, 5. So 6 electrons and 2 electrons with oxygen. So total it is xenon with oxygen double bond means here itself 2 electrons has gone 3, 4, 5, 6. So remaining 2 electrons will be like this. So it is called, it has one lone pair of electron. So it has what shape? Square pyramidal shape due to sp3d2. Why sp3d2? Because how many bond pairs? 1, 2, 3, 4, 5, 6. So 5 bond pairs is 1, 2, 3, 4, 5 bond pairs plus one lone pair. Total it is equal to 6. N is equal to 6 means sp3d2. 1 plus 3, 4, 4 plus 2, 6. I hope it is clear. So this is undergoing what type of hybridization? sp3d2 hybridization, sp3d2 hybridization. And what is the shape of the xenon oxy tetrafluoride? Square pyramidal. I hope it is clear. Next, all these shapes they'll ask in examination. Based on shapes and structures, you'll get questions in the entrance exam. So all the shapes and structures you have to remember. Next, use of noble gases. Use of noble gases, use of helium. Helium is used in filling balloons for meteorological observations. Meteorological observation means weather report based on climate. So helium balloon is used in filling balloons because only hydrogen means it will explode. That's why balloon of hydrogen, combination of hydrogen plus helium. As these two, why these two are used in balloons? Because they are lighter, very much lighter. So that's why they'll flow in air. They'll flow in air. So lighter. So that's why helium is used in filling balloons for meteorological observations. Used as coolant for nuclear reactors. Liquid helium is used as cryogenic agent, cancer killing substances. It is used to produce superconducting magnets for new NMR and MRI system. These two are scanners. MRI scan and NMR scan. This is nothing but it is nothing but scanning machine, which by the use of these MRI systems, we can easily see the brain, lungs, heart of our body, etc. So that's what MRI scanning they'll say, abdomen, stomach, etc. So that's why this is used to produce superconducting magnets for NMR and MRI systems. Next, medical research. A mixture of helium and oxygen is used as respiration mixture by deep sea divers. So oxygen cylinder, not only with oxygen, they'll have oxygen as well as helium. Why? Because helium is lighter in air and helium and oxygen should be there as respiration mixture by deep sea waters, deep sea divers. I hope it's clear. So these are the use of helium. Next, neon is used in discharge tubes. This is used in discharge tube. That's why we'll say fluorescent bulbs for advertisement display purposes. That's when neon is used. So whatever the advertisement board lights we have seen that is made up of neon, fluorescent bulbs and advertisement display purposes will use neon. Argon is mainly used to provide an inert atmosphere in high temperature metallurgical processes and electric bulbs. In electric bulb we have argon. So argon is used mainly to provide an inert atmosphere in high temperature. Metallurgical purposes means extraction of metal and electric bulbs. Argon and krypton are used in light bulbs designed for special purpose. Radon is used in the treatment of cancer by radiotherapy and in radioactive researches. So it is used in the treatment of cancer. I hope it is clear. Continuation. Now questions based on this chapter. This chapter is very small chapter as I told you. Within one lecture only we can finish. So one complete hour we can take for completion of this chapter. So now we are going to discuss questions based on this. Why are group 18 elements are noble gases? Why they are called as noble gases? Because they are chemically inert. As they are chemically inert and has 8 electrons in the valence shell except helium. 8 electrons in the valence shell, in the valence shell or outermost shell, and stability. And they are stable. So that's why they are called as noble gases. Why they are called as noble gases, understood? I hope it is clear. Next question. Why is helium used in diving apparatus? Diving apparatus means sea divers. So alone oxygen, helium and oxygen cylinders will be carried out. Helium along with mixing oxygen cylinders are carried out by deep sea divers. Are carried out by deep sea divers. So it is used because why helium is used in diving apparatus, because helium can withstand the low pressure. Helium will give you, so helium withstands helium under high pressure. Helium is less soluble in the blood. Under high pressure, this is the reason. Under high pressure, helium is less soluble in the blood than nitrogen in the blood than nitrogen. That's why they will take the cylinder consisting of oxygen with a combination of helium plus oxygen cylinders. So a mixture of helium and oxygen is used instead of air. Instead of air, we'll use a mixture of helium and oxygen because under high pressure, as we know, deep in the sea, high pressure will be there. So under high pressure, helium is less soluble in the blood than nitrogen. That's why it is taken as diving apparatus. I hope it is clear. So please note down this point. This point they'll ask in the competitive exam. So under high pressure, helium is less soluble in the blood than nitrogen. That's why it is taken as cylinder along with the mixture of oxygen for diving apparatus by deep sea divers. I hope it is clear. Next question. The only binary compounds of noble gas are fluids and oxides of krypton, xenon, and radon. Why? Because. So what is that? Only binary compounds of noble gas are fluids and oxides, because as noble gas as neon and argon are stable and have neon. This is neon, helium, neon, and argon are stable and have ionization enthalpies very high ionization enthalpies. So it's very difficult to make them react. So only the binary compounds of noble gas are fluids and oxides of krypton, because fluorine and oxygen are electronegative in nature. So that's why they can, and they are called good oxidizing agents. So that's why they only can form with noble gases, that too only with xenon, krypton, and radon. Xenon and krypton only mainly. I hope it is clear. So this type of questions you will get as reasoning type questions. In the exam, they'll give options. Here, I'm not giving options for some questions. For some, I'll give options. Discuss the with respect to the group 18 elements. Solubility. What happens to solubility? The solubility decreases down the group. Melting point and boiling point increases down the group. Solubility decreases. Solubility increases. It is increasing. Solubility increases because the increase of atomic number. Ionization enthalpy decreases down the group. Atomic size increases. So these are the four answers we have. Atomic size increases. Solubility increases. Melting point and boiling point increases down the group. Helium is having lowest melting point. What is the melting point of helium? Helium is lowest melting point. Lowest melting point. It is 4.2 K. I think it is boiling point. 4.2 Kelvin is very difficult to attain the temperature. I hope it is clear. Next question. Explain the following. Fluorine does not exhibit any positive oxygen state because it is highest electronegative element. It is highest electronegative negative element and small size. Small size, we cannot say no need to write small size, only highest electronegative element. So that's why it does not exhibit any positive oxygen state because highest electronegative element is fluorine. So with other element, it shows negative only because the other element becomes positive. So the majority of known noble gas compounds are those of xenon. Why? Because the ionization potential of xenon matches with ionization potential of oxygen gas, due to which what happens? It can form compounds, noble gas compounds, remaining they cannot form. I hope it's clear. Next question. So some more questions we'll discuss based on this. So here itself I write. So question number 6 we'll discuss now because only 5 questions is not enough. So we'll discuss now. Question number 6, match the following. Match the following. They'll ask this type of questions in the exam. List 1, list 2. So please note down because these questions you will not find in PPTs. So first one, A, xenon tetrafluoride. Here first one, it is distorted octahedral shape. Distorted octahedral. As I told you, the shapes are very important. Next B, xenon hexafluoride. And here option tetrahedral. Just matching. We have to do correct matching. This type of questions you will get in the exam, competitive exams. Option C, xenon trioxide. And here 3 it is square planar. And option 4, that is D, xenon tetroxide. Xenon tetroxide. Option 4, it is pyramidal shape. So now the correct options. First option, option 1. So here I write A, B, C, D. First option, what we have? 1, 2, 3, 4. A is 1, B is 2, 3, C is 3, D is 4. Second option, 3, 1, 4, 2. 3, 1, 4, 2. Again, I write here A, B, C, D. I'll write it apart, a little bit far, so that easily we can understand. A, B, C, D. Option 3 I'm writing here. Third option, A is 1, 3, 2, 4. 1, 3, 2, 4. And fourth option also I'll write here. Don't get confused. Here I kept far. So fourth option, what we have? 2, 4, 1, 3. 2, 4, 1, 3. Let us see. So xenon tetroxide has no lone pairs, 0 lone pairs, and all bond pairs. So it has how many bond pairs? 4 bond pairs. So 4 bond pairs means sp3 hybridization. sp3 hybridization with no lone pairs means definitely this should be tetrahedral. So D is 2. D is 2. So D is 2 where we have option straight away we can get this. So answer is second option because in second option we have D2. Remaining all we have. So D is 2. Even A, any one answer you can remember. So XCF4. A is 3 because it is square planar. XCF4 is square planar. XCF6 is distorted octahedral. So 3, 1, 4, 2. So answer is this 3, 1, 4, 2. So like this matrix type questions they'll ask. Next question. Question number 7. Question number 7 now. Matrix matching again. List 1, list 2. So it is multiple matrix match. Matrix match questions. Means the same option we can have more than one. So that's why it's very important. First one, gas thermometers. So this is list 1, list 2. List 1 and list 2. Gas thermometers. First option, helium. So it is P. They have given P, helium. Next, B, beacon lamp. These are all uses of inert gases. Beacon lamp. Option Q, neon. Third option, electric bulbs. We know electric bulbs are used. Electric bulbs. PQR, xenon. Option D, flash bulb. Flash bulbs. S, it is krypton. So these are all based on uses of, and the right option we have to write. So here the answer is A is P. It is helium. Gas thermometers, helium is used. Next, B is Q. B is what? Q. Beacon lamp is neon. Beacon lamp is what? Neon. B is Q. Next, C. C is nothing but electric bulbs are used in xenon, neon, and xenon. So Q and S. Q and S, krypton. So Q and S are used as electric bulbs. Very, very important. And the D, flash bulb. Sorry. Flash bulb, it is xenon. So answer is this. Very, very important. Please note it down. Next question. Question number 8. Question number 8. The number of p pi d pi bonds. Very, very important this question. As I told you, they'll ask everything on structures. The number of p pi d pi bonds. The number of p pi d pi bonds. P pi d pi bonds present in XeO3 and XeO4. Present p pi d pi bonds. This should be pi bonds because they are double bonds. Present in XeO3 and XeO4 respectively are. So simple it is based on structure. So first option 3, 4. Second option 4, 2. Third option 2, 3. And fourth option 3, 2. 3, 2. What can I write here? It is 3, 2. So these are the options. So what is the answer it could be? Let us discuss now. First I'll draw the structure. So I'll draw the structure first in xenon trioxide structure and xenon tetroxide structure. So xenon trioxide we have 3 oxygens, double bond O, and double bond O with one lone pair of electrons. And xenon tetroxide we have all sides double bond O, double bond O, double bond O, double bond O. 0 lone pairs, no lone pairs. So How many p pi d pi bonds we have in this? 1, 2, 3, because it has 3 pi bonds. And it has how many pi bonds? 1, 2, 3, 4. So 4 pi bonds. So it has 3 comma 4 p pi d pi bonds. 3 comma 4 p pi d pi bonds. You can see the structures. I hope it is clear. So number of pi bonds they are asking. Instead of asking number of pi bonds, simply they ask the number of p pi d pi bonds present in xenon trioxide and xenon tetroxide respectively. Yeah, so answer is 3 comma 4. I hope it is clear. Next question. Question number 9. Question number 9. How many lone pairs? How many lone pairs and bond pairs? How many lone pairs and bond pairs are present in xenon OF2, xenon oxidifluoride molecule? They're asking how many lone pairs and bond pairs present in xenon OF2 molecule. So straight away we can say xenon has 8 electrons in the valence shell. So 1, 2 electrons, 3, 4 electrons. So with this, it has one fluorine, one fluorine. It has double bond with oxygen. So remaining how many? One lone pair, two lone pairs. It has how many lone pairs? Two lone pairs. So how many lone pairs? Two lone pairs and 1, 2, 3, 3 bond pairs. So it has two lone pairs and three, because even though it has two electrons, it is considered as only one bond pair, as we already know. So 1, 2, 3, three bond pairs and two lone pairs. So two lone pairs and three bond pairs. So n is equal to 5. N is equal to 5 means sp3d to sp3d 1 plus 3 4 4 plus 1 5. So it is undergoing what type of hybridization? Only sp3d hybridization. I hope it is clear. Question number 10. That's why I have not given options for this. Next question. When a radioactive substance, when a radioactive substance, when a radioactive substance is kept in a vessel, is kept in a vessel, when a radioactive substance is kept in a vessel, the atmosphere around it is rich with the atmosphere. The atmosphere is complicated question. The atmosphere around it is rich with option A, it is neon. Option B, it is argon. Option C, it is xenon. Option D, it is helium. So the atmosphere around it is rich with radioactive disintegration. It gives out alpha, beta, and gamma radiations. In the universe, you already know helium is the second most abundant element. So it should be deal with helium. That's why all the stars formation are radioactive in nature. So the atmosphere around it is rich with helium. I hope it is clear, because helium is inert gas. Helium does not combine, so that's why it is kept with helium. I hope it is clear, because we have to keep a radioactive substance in vessel means we have to take a inert element. So helium is the most inert element of all this. So that's why answer is helium. I hope it is clear. Let us discuss now question number 11. So important questions we'll discuss. So that's why I'm discussing more number of questions I'm discussing. So please note it down. The increasing D character, very important model. The increasing D character. The increasing D character. The increasing D character in hybridization of xenon in hybridization of xenon in XeF4, XeF2, XeF4 and XeF6 is simple. It is option A, XeF2 is less than XeF4 is less than XeF6. First option. Second option, D character means hybridization. sp3d, sp3d2 like that. So second option, XeF4 is less than XeF6 less than XeF2. Third option, XeF6 less than XeF4 less than XeF2. And fourth option, XeF2 less than XeF6 less than XeF4. These are the four different options we have. So first we should know the hybridization. Xenon diploid. Xenon diploid means it has two lone pairs because 1, 2, 3, 4, 5, 6, 7, 8. So it has two lone pairs. Sorry, three lone pairs and two bond pairs. Three lone pairs plus two bond pairs. Why? Because xenon diploid. Xenon means it has one fluorine, and remaining 1, 2, 1, 2. So total it is 1, 2, 3, 4, 5, 6. So one more is there. So it here I keep. So it has 1, 2, 3 lone pairs. 1, 2, 3 lone pairs, 2 bond pairs. 3 lone pairs, 2 bond pairs means 5. 5 means sp3d. What is the option? sp3d. Similarly, xenon tetrafluoride has 1, 2, 3, 4 along with 1. So 2 lone pairs because total 8 electrons now. So 2 lone pairs, 4 bond pairs. So 2 plus 4, 2 lone pairs plus 4 bond pairs. So it is equal to 6. So it is sp3d2. And similarly for XeF6, sp3d3. So XeF4, sp3d2. XeF6, it has sp3d3. So D character is more in XeF6. Next is sp3d2. Least is sp3d. So the order is XeF2 less than XeF4 less than XeF6. I hope it is clear since this is undergoing sp3d hybridization. This is undergoing sp3d2 hybridization means D character is more. This is undergoing sp3d3 because so D character is still more. So answer is this increasing order. I hope it is clear. So this type of questions are important for the exams. Next question number 12. Let us see question number 12. Which of the following two are isostructural? Very, very important. Which of the following pairs are isostructural? Isostructural means having similar structure. Similar hybridization, no, only similar structure. So first option, ammonia and IF2 minus. Sorry, first option, xenon difluoride, comma, IF2 minus. Second option, ammonia boron trifluoride, ammonia, comma, BF3. Third option, NH2BF2, NH2, comma, BF2. And fourth option, we have PCl5, ICl5. PCl5 and ICl. So we have to see. First, we know xenon diploid. It contains simply if it is Number of lone pairs and bond pairs and hybridization matches. So automatically the structure is also matching. So let us see number of bond pairs and lone pairs in XCF2. XCF2, let us see first option verification. So XCF2, it contains how many bond pairs? Xenon contains 3 lone pairs and 2 bond pairs, since already we know. Because xenon contains 1, 2, 3, 4, 5, 6 lone pairs and 2 bond pairs, one with F, one with F. So it is 3 lone pairs, 2 bond pairs, so it is 5. N factor is equal to how much? 5. So our hybridization is sp3d. So the lone pairs and bond pairs should match. Next, IF2 minus. So let us take into consideration in the same IF2 minus. So iodine has how many valence electrons? 1, 2, 3, 4, 5, 6, 7 electrons. And minus means one more electron is gaining. So it has how many lone pairs? So 2 hydrogen, 2 fluorines, and 2 fluorines. So it has 2 bond pairs, 3 lone pairs. 1, 2, 3 lone pairs. So 3 lone pairs and 2 bond pairs. So definitely both are having N is equal to 5. So they undergo what? sp3 dehybridation. Hybridation is same and also structure is also same because they contain 3 lone pairs, 2 bond pairs, 3 lone pairs, 2 bond pairs. So answer is first option directly. Like that you can check for remaining, but anyway it will come only one option since this is single option correct. So that's why 100% you'll get first option. I hope it is clear. So this is question number 12. Next question number 13. Since more questions we have to do because these small chapters, so only important questions I'm doing now. The shape of xenon XeF5 plus ion is the shape of XeF5 plus ion is plus means one electron is going in this is first option A pentagonal, option B octahedral, option C square pyramidal, option D is trigonal bipyramidal. Trigonal bipyramidal. So in this, what is the answer? We have to check. So trigonal bipyramidal, square pyramidal, pentagonal, octahedral. Let us see the shape. So this question is very, very important. So let us see first. XeF5 plus means xenon has 1, 2, 3, 4, and 5, for example. So it has how many electrons? 5 electrons. Still how many more electrons? F plus means one lone pair because plus means one electron is gone from xenon. So it is nothing but it has 1, 2, 3, 4, 5. 5 bond pairs plus one lone pair. So one lone pair. So 5 bond pairs plus one lone pair means is undergoing sp. Total it is 6. So it is undergoing sp3d2. So sp3d2 with one lone pair. The shape is square pyramidal. Shape is what? Square pyramidal. So answer is third option. I hope it is clear. So shape is what? Square pyramidal shape. Very, very important. Next question. So more 2 questions we'll do, then we'll wind up this session. Question number 14. The fluids of xenon. Very, very important. Connecting questions. Tough questions only I'm doing here. Easy questions, I'll give it as PPTs. The fluids of xenon with zero dipole moment is with zero dipole moment. Dipole moment is nothing but the moment of electron from the element to most electronegative atom. It is called dipole moment. So is option 1. So all these points you have to gather. XeF6 Option 2, XeF4. Option 3, XeO2F2. And option 4, XeF6, XeF2. So these are the fluids and along with oxides. So 14, question number 14. So the fluid of xenon with zero dipole moment is. So we have to find out which fluid is having zero dipole moment. So answer is XeF4. Why it is XeF4? Because xenon has 1, 2, 3, 4. So what happens here? Electron is going from xenon to fluorine, xenon to fluorine, xenon to fluorine, and xenon to fluorine. So as the electron is going from xenon to fluorine, what happens on the four directions? This side, it is going towards this side also. So opposite forces cancel out each other. Opposite dipole moments, opposite forces cancels each other, cancels each other. So due to which what happens? Due to which what happens? Mu is equal to 0. That is dipole moment is equal to 0 for this compound. I hope it is clear. So answer is second option, xenon tetrafluoride. Next question. Last question in this session. So with this, we'll close the class, close this session. Next session, we'll discuss questions based on 17th and 18th common. So next question, I'm just writing it on the board. So please note down. In the preparation of compounds of xenon, in the basic question, in the preparation of compounds of xenon, in the preparation of compounds of xenon, Bartlett, Neil Bartlett is a scientist who prepared xenon compounds, had taken O2 plus PTF6 minus as base compound. This is because as base compound, this is because why? First statement only I have to given. Option 1, both oxygen and xenon have same size. Both oxygen and xenon have same size. This is NCRT based question. Option 2, both oxygen and xenon have same electron gain enthalpy, have same electron gain enthalpy. Option 3, what is EGE? Electron gain enthalpy. Next, both oxygen and xenon have same ionization enthalpy. And fourth option, both xenon and oxygen are gases. Both xenon and oxygen are gases. So which is the right option? So many of you know. So since the ionization energy of oxygen is 1175 kilojoules per mole, and even xenon is also 1170 kilojoules per mole, almost they are similar. So that's why he tried. This in the first slide only I explained. I hope it is clear. So answer is what? Answer now. Since both oxygen and xenon have same ionization enthalpies, that's why they are compared as base compound. So that's why O2 plus PTF6 minus as base compound, because he could prepare successfully O2 PTF6, and from that he he prepared one more compound, first noble compound, that is XePtF6 complex compound. So xenon platinum hexafluoride is the first noble compound prepared in the lab. First noble compound. First compound prepared in the lab. Why he has taken base compound as oxygen? Because the ionization enthalpy of both xenon and oxygen is same. So that's why he could take that as base compound. I hope it is clear. So maximum number of questions we have discussed in noble gases, and more number of questions we'll discuss in noble gases in the next session. So I hope it is clear. So with this, I'm ending this session. I'm ending this session. Thank you all. So please do